Hello and welcome to this Easy GUI tutorial video. In this video we're going to be creating a checkbox, and we're going to get into a little bit more detail about the UI Manager class, as well as how to size your controls on screen so that they appear the desired size. Now before we get started, I'm just going to create a checkbox control real fast so that you can see real quickly how easily it's done. We'll create a new game object here and we'll just call it checkbox. And we'll drag our UI state toggle button on here. And the UI state toggle button can actually have an unlimited number of states that it'll toggle through. But right now we're just going to have two, so it's a checkbox. And we'll name the first state checked. And we'll create a new state and call it unchecked. And then we will assign it a material. And we can go ahead and define its appearance here for the checked state. We're going to drag our checked texture on. For the unchecked, we will drag the unchecked. And you can also use the control editor for this. If you're using Unity iPhone, you would drag it over here instead. You select the states at the top. And we'll just build our atlas. And we'll check pixel perfect. And you can see there is our checkbox. If we hit play, you can see that we can check it on and off. And that's all there is to it. Now let's talk more about setting up our Easy GUI scene. We talked in the first video about how every Easy GUI scene needs to have a UI Manager object in the scene, and that's what polls for and dispatches the input. So let's just go through item by item here and look at it. The first thing is the pointer type. This allows you to select what type of input device you want to use for your controls. And obviously mouse is your mouse, touchpad is for things like iPhone and iPad. Soon we will probably be able to support Android. And ray is a special pointer type useful for things like first-person shooters. You can see a demonstration of that in the showcase video, also on the Easy GUI webpage. And these are combinations of the two. Now what's really handy in Easy GUI is you can easily switch back and forth. Let's say if you're making an iPhone game, you can deploy your game with the touchpad selected, but when you're editing your game and testing it in the editor, you can just switch over to mouse and use the mouse. And when you're ready to deploy or test on the device, you can select touchpad. And Easy GUI supports full multi-touch, so you can touch and use multiple controls at the same time. Now let's talk about the drag threshold. The drag threshold is the number of pixels that the pointer has to move before it is no longer considered a click. And this is useful, for instance, on touchpad devices. If you touch on a button and you move your finger beyond the drag threshold distance, then when you let your finger back off the button will not consider it a click or a tap. And that can make your user interface a lot more friendly when using a touchpad device. The next one, ray drag threshold, is basically the same thing, except for the value that's put in here is not in pixels, but rather in world space units figured at the end of the ray. So if your ray is cast a certain distance into the scene, it's the distance between the end of that ray from when the click was started. Now let's look at the mouse and touch depth. This is the distance from the camera into the scene that mouse and touchpad events will be raycast into the scene. So you can use this, for instance, if you have a first-person shooter or something and you want the player to be able to touch on the screen or click on the screen to interact with objects in the world, but you want to limit their arm length, so they can't reach a mile away and activate a button or something. So you can use that for that purpose. By default, it's set to infinity, so that a regular menu, it doesn't matter how far away the controls are from the camera, it just works. But if you want to, you can set this to another value to limit the depth that the player can touch. The ray depth is basically the same concept, only it applies to the ray pointer type. The mouse and touch mask is the layer mask for mouse and touchpad events, and this allows you to mask off objects in other layers so that you only test against, for instance, your GUI layer. And this is pretty important because if you have a lot of colliders in your scene, you typically only want to use Easy GUI to test for hits against your UI objects in the scene. So what you want to do is put all your UI objects into a like a GUI layer. So for instance, my checkbox here, I can set it into my GUI layer. I have a layer defined as GUI. And by the way, how to do that is you can hit add layer and then just type in here something for your layer, and then it shows up in your selection. So we can set that to the GUI layer. So let's go back here. But we can set this to nothing, and then we can pick, it's only going to do GUI now. But that defaults to everything just so you can get up and running quickly. The ray mask is basically the same thing, except it masks the ray pointer type rather than the mouse and touchpad. And that's useful. It's useful to have two different masks so that, for instance, you can use the mouse and touch mask for on-screen UI. So let's say you're making a first-person shooter for the iPhone. You can touch buttons on the screen, like a jump button or a shoot button. And then the ray mask can be used to mask against in-world objects that you want to make interactive. The next is the action axis. This is the name of the Unity input axis that's to be used for the action button, as it were. So for instance, it defaults to Fire 1, and if I go to Edit, Project Settings, Input, you can list the axes here, and the default for Fire 1 is mouse 0, which is usually the left mouse button. So if I click the left mouse button with this setup and I'm using the ray pointer type, then every time I click the left mouse button, it's going to be like I'm clicking on whatever's in the world. It's kind of like my action key or action button. So you can set that up in Unity Input. If you're using iPhone or iPad, there is a special button type right here called UI Action Button, and you can put that on the screen, and when you hit that, then it'll do the same thing. Warn on non-UI hits, that is an option mostly useful for debugging. So when you have objects in your scene that are non-UI objects, you can use that and it'll warn you when a raycast is done against an object that's not a UI object. But if for some reason you want to do raycasts against non-UI objects, you can uncheck that and it won't warn you. The UI camera is the camera to be used for the mouse and touchpad raycasts, and the ray camera is the camera to be used for the raycasts, and the ray will be fired from the center of that camera. So again, let's say if you're doing a first-person shooter for iPhone, you can use the UI camera to render just your UI elements on the screen, and use the ray camera, and then use the ray camera to actually be the player's first-person view in the game world. Block input, that basically turns off all input. It won't poll for any input when that's checked. That's mostly going to be used internally. You're not really going to need to use that most of the time, but it can be useful if you're doing a transition of some kind or a cutscene. This can be set in code, and it will not allow any input during that period of time. And then default font, that lets you specify a default font. That's useful for if, for instance, we want to create a label for our checkbox. We can type text in here, and it will automatically generate a text mesh for us in a child object, and that'll show up here. And we can select it and set it up, scale it however we want. If we don't have the default font specified, then it's not going to create that automatically when we start typing text. And that pretty much covers all the settings for the UI Manager object. Now let's go back through and create our checkbox once again, and we'll look at it in a little bit more detail. So again, we'll create an empty game object, and we'll call this checkbox. And we'll put it into our GUI layer so that later on we can filter all our raycasts just for the GUI layer. So we're saving performance because we're not testing the rays against all of the colliders in our scene. Now we'll attach a state toggle button, and we'll assign a material. Now when we assign a material, what that does is that's basically telling EasyGUI what atlas it's going to build the graphics for our control to. Now that's important because if we're wanting to reduce our draw calls, then we need to keep as many objects as possible using the same material so that they can be batched together. Now if I were to create a second checkbox or a slider control or a button or whatever, then I would want to assign it to the same material as I've assigned my checkbox so that it will get built to the same atlas and will use the same material and can be batched with it, and together it will only be one draw call. Next, we'll start defining our states. So again, since this is a checkbox, we're going to have a checked state, and then we'll add another state and select it, and we'll name this one unchecked. And you can see here we can drop down and select the states that we've created. We can just continue creating states every time we click the plus button and see we've created some additional states. We can then remove those by clicking the minus button. So let's go back to our checked state, and you'll see that we have the ability to assign a texture to that state. So we have the checked state, we'll drag the checked texture on there, and if we go over to our control editor, we can also do it this way. We can select the unchecked state there and drag it over, and you can actually drop the texture anywhere in this box and it'll go over there. And if we had Sprite Manager 2 running here, we would actually have a timeline and we could make this animated. So we could drop multiple textures on here, and when it goes into this state, it'll play whatever animation we set up here. Now that we have set up the appearance of our checkbox, we can click on Custom and Build Atlases. And by the way, we can also go down here if we want to instead, where it lists the material, and click this little gear icon and Build Atlas. And what this will do is it'll only build this atlas, the atlas for this material, instead of all the different materials we may have in our game. So we'll go ahead and click Build Atlas, and that brings up our Build Atlas menu. The Atlas folder, that's the folder in the project folder that it's going to put the new atlases in, and we can name that whatever we want, but that's where it's going to put the atlases. The max atlas size is going to be the maximum dimension of the atlas that it generates, and if it cannot fit all of our source graphics into that single atlas, then it'll actually have to size them down, and we'll lose quality that way. So we want to try to keep it so that we stay within that atlas size, and if we get beyond that, then we'll just have to use a second material, and that'll be one more draw call, but it's better than losing a ton of quality when we size our graphics down. Padding is the number of pixels that it will put between the graphics when it puts them onto the atlas, and that's useful so that we don't get bleed from neighboring graphics in our controls. So you want to leave that at least at 1. The next setting is Trim Images. And what that does is if we have a source graphic that has some empty pixels around the edge of it, it'll actually trim that down so that it doesn't take up extra space on our atlas. And this is also useful in conjunction with the texture offset anchor method that you can see here. I won't go into detail how that works. There's a Sprite Manager 2 tutorial video that covers that if you want to go check that out. The texture offset feature is mainly only useful if you're using Sprite Manager 2 because it's very useful for animation. But anyway, I recommend you leave Trim Images on because it'll save you space if you have empty pixels around your controls, and that way you don't have to worry about trimming them yourself. Force Square, that's useful if you're using iPhone and you want to use PVRTC compression, because PVRTC compression requires that your textures be square. So you can check that if you want to make sure you can use that. Scan Project Folder, this is a very important setting. If you're using Unity iPhone, what this will do is it will only scan your project folder for prefabs that contain controls or sprites and build atlases off of those. If you only have sprites or controls in the current scene and you only want to build for them and they aren't linked to any prefabs in your project folder, then you want to uncheck this, and that will build atlases for those sprites. Now, if you have sprites or controls in your current scene that share a material with sprites or controls in another scene that's not open, when you build atlases for the sprites in the current scene, it will update those sprites with the new locations, the new UV coordinates of the atlas that it builds, but it's not going to be able to update the sprites in the unopened scene, and tell them where the new locations are on the atlas. And in fact, if they use different graphics, their graphics won't even be included on the atlas. The reason for that is because Unity doesn't give any way for objects in a non-open scene to be accessed. So what you'll want to do if you're wanting sprites and controls across multiple scenes to share the same material in the same atlas, you'll want to associate all of those with prefabs in your project folder, and then check the Scan Project Folder option. And what that'll do is it will scan those prefabs in your project folder, and then when you open the scene that contains those sprites, they will get updated from their source prefabs. That also means if you make changes to the appearance of your sprites or controls, that is, if you change their source textures and things like that, you want to do so to the actual prefabs directly in your project folder. Otherwise, when you make the changes in the scene, it can override those settings in the prefabs so that they don't get updated when you reopen that scene. So, rule of thumb is, if you're using prefabs to make sure that all your sprites get updated, even the ones that aren't in the open scene, you want to make all your changes to the prefabs directly, not to the instances in your scene. So right now, since our checkbox is just in our scene and not connected to any prefab, we'll uncheck this option and go ahead and hit Create. And you'll see down here it says 1 atlas generated. Now we would be able to see it right now, except that you can see here the width and height are set to 0. So if we go ahead and let's set that to some arbitrary value, 10 by 10, you can see here we can already start seeing our checkbox. But if we go to our game view, that's not really going to work, because right now our main camera is orthographic and the orthographic size is 100, and that's just way too small. So you could eyeball it. You could use your scale, do it like this, or we could change it this way, but that's not very precise. So one option you have is to use pixel perfect. If we check that, it will make it pixel perfect. Now, there is a peculiar thing in Unity where sometimes when you're in edit mode, it won't report the correct values for the game view. Sometimes it'll actually be reporting values for the scene view. And so sometimes this won't look correct when you check pixel perfect. But when we run the game, it'll always be correct. When you stop it, sometimes it'll get resized to some other size. Now, auto resize is useful for animating sprites and controls, and that's when the dimensions of the animation actually change. It will automatically change to accommodate so that it doesn't warp. We won't really talk about that since that's more of a Sprite Manager 2 issue. But to talk a little bit more about the pixel perfect setting, what that does is your control will always appear pixel perfect when that's checked, provided that you have the correct camera assigned. So if you have a separate UI camera, for instance, that's rendering your UI, you want to make sure and have that set here so that it knows which camera to size itself for, so that it's always pixel perfect. So if you want to run your game in multiple resolutions, this will make sure that it's always pixel perfect regardless of the resolution. Now, a lot of times you may not want it to do that. You may want the control to always occupy the same percentage of the screen regardless of resolution, for instance. When you want to do that, you want to turn off pixel perfect. Now you can turn it on to get a default size going and then turn it back off and work from there. But let's say, for instance, you're wanting to target a default resolution of 1024 by 768. Well, you may not want to have your game view here set to that size because that'll take up a lot of your screen space. So what we can do in that case is we can use the Sprite Sizer menu option. So we can click on Custom and go to Size Sprites, and we can apply it only to the selected sprite if we want to. We can apply it to all the sprites in the current scene. We can apply it to all our prefabs, which will scan our project folder. We can have it automatically disable pixel perfect as it goes. If it encounters any sprites that already have pixel perfect checked, it'll uncheck that. And now we tell it our target resolution. So if we said we were targeting 1024 by 768, this is the screen height, so we would enter 768. And then we would choose the render camera. And bear in mind this all applies only to orthographic cameras, because otherwise, obviously, with a perspective camera, the size on screen will change based on distance. So here we would select the camera that we're going to use, and then hit OK. And now it's sized for 1024 by 768. So if we choose that and we maximize on play, we can see that it is set to be pixel perfect at our target resolution. So let's just reiterate one more time. When we don't have pixel perfect checked, if you notice, this has taken up a certain percentage of the screen area. When we run it maximized, it's still taking the same percentage because it resized. Now if we enable pixel perfect, it's going to set it to be pixel perfect at the current viewport size. When we run the game, notice it actually sizes down so that it's still displaying on the same number of pixels. So it's a smaller percentage of the overall screen size than it is over here. If we were to run it at this lower resolution, you can see it sizes up so that it's still displaying on the same number of pixels, regardless of the resolution we're using. And by the way, when you're first setting up your control, sometimes if you make changes to the source graphics or something like that and you build your atlas, it may not be reflected here in the scene immediately because of the way Unity updates in the scene and game views. Sometimes you may have to hit play real quick and then turn right back off, and then it'll be updated and you'll see all your changes reflected. Now, one final thing we're going to cover is if we go to the control editor, obviously when we check this box, we want something to happen in the scene. And as you saw from the previous video, one of the ways to do this is to set the script with the method to invoke, and then type in the actual name of the method without parentheses to invoke. So let's say we have this menu controller object that we want to use, but as you can see, it's got multiple entries on our list. Well, that doesn't help us a whole lot because it doesn't tell us which script on the menu controller object we're going to be picking when we choose one of these. So instead what we can do is look over at our control editor, and it has a special drop-down for this. So we can actually choose menu controller, and it'll show us which script we're choosing when we choose the menu controller. So we actually want the menu control script. We'll choose that, and then we can type in the method. And that concludes this Easy GUI tutorial video. I hope you found it helpful, and thank you very much for watching.